Hello there, welcome to Pre-Cal Lecture 3.5, where we're going to be talking about the slopes of lines. Hopefully you've had every bit of this before, possibly in Algebra 1 or even before. So section 3.5.1 is called Finding the Slope of a Line Given 2 Points. Alright, and you'll be taking notes on your own paper today. So let's draw a line. And we will label a couple of points on that line. Let's say this is point x1, y1, and this is point x2, y2. All right, so we can make a right triangle out of those 2 points. And what we call this distance here would be we can think of that as the run, and we can call this vertical part the rise. Okay, so the slope is equal to y2 minus y1 over x2 minus x1. Now you can reverse those. You can do y1 minus y2 over x1 minus x2. You'll get the same answers because then the signs will take care of themselves, but you can't do y2 minus y1 over x1 minus x2. You have to have consistency in the 2 and the 1. All right, so that's what we call the change in y over the change in x. Okay, so this delta just means change. You've seen that probably in your chemistry class. We call that the letter m, and we can also call that the rise over the run. Okay, so all of that is just a way to calculate slope, or a way to signify slope. So let's do some examples with 2 points. Find the slope of the line that passes through the point 1, 1 and 5, 5. Okay, well, I'll go ahead and label them so we don't get anything backwards. We'll call this x1, y1, x2, and y2. So the slope is going to be y2, 5, minus y1, which is 1, over x2, which is 5, minus x1. That's going to be 4 over 4, which is equal to 1. Now let's say I chose to do y1 minus y2 over x1 minus x2. So that'd be 1 minus 5 over 1 minus 5, which is negative 4 over negative 4, which is also equal to 1. Okay, so as long as you keep the 1s and 2s consistent, then the sign will take care of itself. But you can't, if we did y2 minus y1 over x1 minus x2, then we would have a problem. Okay, so let's do another couple of examples. Find the slope of the line that passes through 2, 0 and -3, -7. All right, so I'm going to go ahead and do it the traditional way, the y2, -7 minus 0 over x2 minus x1. So -3 minus 2. That's going to be -7 over -5. The negatives will cancel and you have 7 over 5. All right, so pretty easy, right? Put a lot of these on the test, right? Okay, well, maybe not a lot, but you'll get one or two. Okay, and let's do one that's kind of a special case. So you want to find the slope. Of the line that passes through 2, 4 and 2, 7. Okay, so our slope is going to be y2 minus y1, 7 minus 4 over x2 minus x1, 2 minus 2. That's 3 over 0, which is undefined. When that happens, what that means is that it is a vertical line. Okay, the slope is equal to infinity. All right, so vertical line, you really can't count the slope, can you? Because the rise is infinite. I mean, the rise, you have a rise, but you don't have a run. So you've got a vertical line there. Okay, so let's go ahead and move on to our next subsection. That's going to be 3.5.2, which is interpreting slope from a graph. Okay, let's give you some examples here. So I'm going to draw 4 different graphs, coordinate plane, the x and the y axis. And the first, I'm going to draw a couple lines. So let's draw one like that. So this is a negative slope, but it's shallow, so the slope is kind of small. All right, so that m number won't be all that big. It'll have a negative in front of it, and it might be -1/2 or something like that. Let's do another. Yeah, let's get a different color here. Let's say we have something like this. So that's still a negative slope. It's not a vertical line. It has some run to it. But it is, at least from an absolute value standpoint, it's large. That slope might be -100 or something like that. Okay? So still negative. So it's going, if you put a marble on it, it would roll down, right? Or down from left to right. It's going down from left to right. Okay. Let's draw another scenario. Pretty famous situation. And this is one actually we drew not long ago on a different lecture. The horizontal line. The slope for a horizontal line is equal to 0. It's all run but no rise. Okay, so it's 0 over something. So this is a horizontal line. Okay, let's keep going with the different scenario. So you just need to be able to see graphs of a line and kind of know what's going on. So if you do a mathematical calculation and you make a mistake, then you can find it if you know that the slope should be positive or negative. So let's say we have something like this. Well, this is a positive slope. But it is a small positive slope. So maybe something like a half or a third. Okay, but it is positive because left to right it's going up. Something like this, that's going to be a positive slope. Still going up left to right. But that number is going to be large. So maybe that's a slope of 10 or something like that. So it's going to be a much larger number than the green line we have here. Okay, and then finally, we talked about this on one of the problems that I just worked. All right, so we would have, in this case, the slope is undefined. Okay, so the slope would be infinity. You'd have a 0 in the denominator. So this is a vertical line. Now, the equation of that line in this case would be, if this is a some value c, would be x equals c. The equation for the line in this case, if it crosses there at c, would be y is equal to some number c. So let's say it's 5, and let's say this is 7, x equals 7, or y equals 5. But you would have the normal for these that have a slope. You'd have the what you've seen before, which we're about to talk about. You can do that y equals mx plus b, where m is the slope and b is the y-intercept. That works for here. But over here, you're going to have y equals a number or x equals a number. Okay. So let's move on to the next subsection. This material isn't hard, but this lecture is a little longer than average. So 3.5.3 is writing an equation in slope-intercept form. Okay, so let's say we have this. AX plus BY is equal to C. This is called standard form. And in my opinion, it is worthless. because you can't get anything just by looking at it. You don't really know about the line. Does it have a positive slope? Does it have a negative slope? Where does it cross the y-axis? Etc. A much more useful, we're going to go over a couple of different very useful line equation forms, is the slope-intercept form. And that is y is equal to mx plus b, where m is the slope and b is the y-intercept. Okay, so let's use that. Now you can be given that. In fact, let me write this down, because you'll have to do this on the homework. If a line equation is given in standard form, solve for y to get it in slope-intercept form. Okay, so all we would have to do is move that ax over to the right, divide both sides by b, and we have y equals something, and that will put this in slope-intercept form. So you have to do that on the homework a couple of times. So, but let's start with an easier one. Find the equation of the line with slope equals -2 and y-intercept equals 5. Okay, so we can put this in, we're not given a point on the line, so we've got the information we need. It's y is equal to mx plus b. M is -2. Let me just go ahead and write down mx plus b. So that's going to be y is -2x plus 5. Let's squeeze another one in here. Let's say the slope is 1/2 and the y-intercept is -6. Then that's just going to be y is equal to 1/2 x minus 6. So you have those two things. You have the equation of the line. You know it's kind of a positive shallow slope, and it crosses the y-axis at -6. This is a little bit steeper negative slope. It crosses the y-axis at 5, so you can draw the line. All right. So let's draw using slope-intercept form. So we're still in 3.5.3. I want to draw or graph a couple of examples here. Let's graph y is equal to -2/3 x plus 1. All right, so x-axis, y-axis. Let's make some tick marks here. About 1, 2, 3. Right. That should be good enough. Okay, we know it crosses the y-axis, at 1. So I've got a point there. Okay, so it goes it's rise over run. So run is over. We would go over 3. 1, 2, 3. And then the rise is negative, so we would go down 2. So 1, 2, 3, and down 2. 1, 2. There's our second point on the line. So run is equal to 3. Rise is equal to negative 2. So now we have 2 points on the line. And that's all you need. All right, let's do another one real quick. Let's graph y equals 1/2 x minus 3. All right. We'll just make some tick marks here. So I know the y-intercept is negative 3. So I've got a point right there at negative 3. The run is 2, so over 2, 1, 2, and the rise is 1, so up 1. There's my 2 points. And there's my graph. So positive slope crosses the y-axis at negative 3. Okay, so that's how you can do a quick sketch of a graph. And I don't know if I ask you to sketch the graph on any of the homework. I do ask you, does it increase or decrease from left to right in some cases, but you don't really have to sketch the graph to do that. But it is useful to be able to sketch the graph. Okay, finally, super important form of a line, form of the equation, is the point slope form. So this kind of stuff is useful all the way up through calculus. So you've got to memorize it just like the slope-intercept form. It's y minus y1 is equal to the slope times x minus x1, where m is equal to the slope and a point on the line is x1, y1. So you can get that. You can also convert that to slope-intercept form pretty easily just by solving for y. All right, let's do a couple of examples. So let's write the equation of the line in point slope form. So I've got a point at negative 1, 3. And I'm given the slope. I don't have to calculate it. On the homework, you may have to calculate the slope. You're given 2 points. Is equal to negative 1/4. If you're given 2 points on the line, you can just pick one of them. You'll get the same equation when if you were to change it to slope-intercept or standard form. All right, but you could use, if you're given 2 points, you could use either point. Okay, so it's y minus y1, that's 3, is equal to the slope, negative 1/4, times x minus negative 1. So that's going to be y minus 3 is equal to negative 1/4 times x plus 1. I do want you to do that part. The two negatives make a positive. And don't put this in standard form. Don't put this in slope-intercept form. It's asked for point slope form, so that's what you need to give. Okay, let's say given y minus 2 is equal to 2/3 times x plus 1, what is the slope? Well, that's pretty easy. It's sitting right there. It's 2/3. And what is a point on the line Okay, well, a point on the line, you take the opposite sign of these 2 points. So the x point is -1, the opposite sign right here. Now, if this were just x and there wasn't a plus or a minus something there, it would be the point on would be 0. X is equal to 0. But you've got a number here. Take the opposite sign. If this were -1, if this were x minus 1, it would be +1. But you take the opposite sign of -2, that's 2. And so a point on the line there. And then you could test that by putting it back into the point slope form and seeing if it matches. All right, just one last note before I let you go for the homework. We'll discuss the homework just a little bit. The note is the slope of a perpendicular. I'm not sure how to spell perpendicular. That may be an E there, but I'm going to go with an I. Perpendicular line. So the symbol for perpendicular would be like that. Is the negative reciprocal of the original slope. So let's say your line has a slope of 7/8. Then the perpendicular slope would be 8/7. You flip that and change the sign. Okay? You would still use one of the same points on the line, but you could get the equation for a perpendicular line. So what I mean by that is let's say we have a line like this. A red marker just fell. If you want to get the slope of a perpendicular line, all you need is the point on the original line, which you have there, and it's perpendicular, and the slope of the red is the negative reciprocal to the slope of the green. Okay? So the homework is just worksheet 3.5. Let's bring that into view. So number 2 is a little bit of an interesting one. It's a little bit of an algebra equation using your formula for slope. We've got one with fractions. A line that is parallel, number 4, will have the same slope. It has the same slope as the original line. I think I just gave you the answer on that pretty much. Perpendicular, parallel. You may have to, so we have the situation where we have an equation in standard form, solve for y, and you get that in slope-intercept form. Same thing here on number 9. And number 12 and 13 also are given in standard form. If you need to get the slope of that, just solve for y, and you'll be in slope-intercept form. So yeah, so hopefully you will not find this too difficult, and I'll talk to you on the next one.